All right, so let's look at what we're doing with this donor recruitment research study now that we actually know that this is a chi-squared test for homogeneity. It is a chi-squared test for homogeneity because we can treat this random assignment as though they are separate populations because of that random assignment. So instead of thinking of this as one sample with two variables, which is when we do our chi-squared test for independence, we have three separate samples, one from the opt-in, one from the opt-out, and one from the neutral, and then we have the results from those, which makes our work a little bit more of a pain in the butt when it comes to writing this null hypothesis. In fact, I had an old video that I had to replace because I wrote down the null was just that the two variables here were there was no relationship between them. I used the independence words instead of the homogeneity words. So who knows what past me was thinking. But let's go ahead and write up what our null and alternative are for this situation. So in this case, our null is that the category proportions are the same for all populations or treatments. And of course, we don't want to leave it this generic. We want it to fit our situation and be something that someone could understand the context of the study. So the proportions of subjects. I guess I don't really want to say subjects because I kind of want to make it like, I see a terrible button. I'm going to have to go all the way forward. This is going to be terrible. Very bad things have happened. Okay, whew. The proportion of, I did not hit the backspace. I hit the actual back button. That was a rookie mistake. All right, the proportion of people who do and don't choose to become organ donors. So all I am doing in this first part right here is matching this, the true proportions for those categories. So my categories here within each of those different random assignments was becoming an organ donor or not. We only have two, so we're pretty lucky here. It could have been more, right? But right now, these are the two things. And I got rid of that word subject because subject made it seem like it was the sample itself and not all people. So I'm trying to be like the population proportions, right? Like this is going to be true no matter what. And then we'll say is the same or are the same. Proportions are the same. My handwriting is horrid today. For all recruitment strategies. And I don't need to write them all down, though I could. Pretend I finished strategies. All right, so that is my null hypothesis. The proportions are the same across all those different recruitment strategies. We know it's not true for our sample. The question is whether it is so different that we can say something is going on. And then our alternative hypothesis, same thing, but not the same. Right, so the proportion of people who choose to become an organ donor or not an organ donor, those proportions are not the same across all of our different recruitment strategies. So let's go ahead and see how we would do this in StatCrunch because my old video relied on the TI-84, which is the worst. So in StatCrunch, this is actually 1,000 times easier if we have raw data. With summary data, it's kind of a pain. We have to make a column for our different populations. It doesn't matter which way we choose to do this. I just match what was in those bullet points on this that was given to us. So we had opt-out, opt-in, and neutral. And so I just matched those. And then I put down organ donor yes. We were given numbers 41, 23, and 44. And then I did need to create, because it wasn't really given in that summary, our organ donor no. So if there were 50 total subjects in that opt-out recruiting strategy, well, then I needed to make sure that I had 9 who said no. That gives me that 50. And I'll double check my math when I do the actual chi-squared tests. So the weird thing about StatCrunch for our chi-squared tests is that both the chi-squared test for independence and our chi-squared test for homogeneity, as I said before, named the same thing, in StatCrunch, but they don't have like a drop down, right? Goodness if it had its own little area where it says chi-square tests. We don't have one for our chi-square tests that we really think of more often when we have this two-way table, because they are inside of our two-way tables. In fact, you were probably seeing this as one of the options as we did contingency tables earlier and just never really thought about it. So our two-way table is a contingency table. Like I said, we're in a weird land where we're doing this with summary data as opposed to having some raw data. So we'll do with summary. And then it has, where are our columns? Well, the actual numbers are an organ donor yes and organ donor no. And then my row, the labels, I put into that strategy column. So this is going to give me two columns. It's going to basically create a contingency table that looks just like what I have here in StatCrunch. But you can see here, I have the option. It says, do you want to do a chi-square test for independence? It's not what we're doing. We're doing a chi-square test for homogeneity, but the mechanics are identical. It's just the hypotheses that change. So we're going to go ahead and say that's cool, do that, and compute. And so here we have that beautiful table. We've got those numbers at 50, 55, and 56, so I could double check my math. And we have a chi-squared test statistic right here. And so we have this chi-squared test statistic, much like our t-distribution. It comes with a degree of freedom. Just in case you wanted to know that degree of freedom, we mentioned it above, but it is the number of rows minus 1 times the number of columns minus 1. So if we look back at this thing, we have 2 columns, so 2 minus 1 is 1. We have 3 rows, 3 minus 1 is 2. 2 times 1 gives me a degree of freedom of 2. And then we have our chi-squared value, which is adding all of those like observed minus expected over expected, just like we saw before, and we get a p-value out. So that p-value is very, 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 very small, as you would have expected looking at this very different proportion in that opt-in group. And so we could finish this up by saying, okay, since this is less than any reasonable alpha, we can reject the null, and we can say there is enough evidence. Come on. She hates me. Maybe I'll type instead of writing. She finds that less annoying. Nope, don't want that. I want this. Boom. There is enough. Ooh, I need to make her bigger. There is enough. Come on. Yes, I'm done moving it. Evidence to conclude that the proportion, this is always exciting when you guys get to watch me type, portion of people who will choose to become an organ donor or not is not the same for all recruitment strategies. And this alone typically upsets students because they like want to write more about being like, well, opt-in is worse, but like from a testing standpoint, this is all we get to say at the end of the test, right? We can say, based on the data, it appears that the opt-in strategy has blah, 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 blah. But we don't want to say this in our conclusion. Our conclusion is going to be following directly from the test that was done. There's just sort of this like post-hoc thing we do after the test to say, okay, and it looks like the opt-in strategy is a bad one. So if you want to add those types of things, especially as we move into the final little project, data project piece, just do that in a separate sentence of sort of like enter opt-ins looks like it is a much lower proportion. And it does look like there's not a huge difference between those other two strategies. In fact, you might even want to do, like I said, in terms of like a post-hoc analysis, you might even come back here and be like, wait a minute, what if I got rid of, let's just delete this row, and let's redo that exact same thing. So we're going back to my table, contingency with summary. These two, this one, leave it with that chi-squared test for independence. You can see now we have a big fat p-value. The opt-out versus the neutral. We can't say that there's a difference in the actual recruitment from those recruitment strategies. So all of that power, all of that, the p-values, right? All of the unusualness is coming from our opt-in group. But again, that is above and beyond, and really all we need is this at this point. Just wanted to like address that there are these things that we do as statisticians sort of after the fact to be like, well, I'm curious. Now there are issues with that because then we're doing multiple tests, but that's a whole different lecture for a whole different day.